relationship for two quantities. So looking at the green one and the blue one, what do you see? What are the two quantities that they have in common? So looking up here, right, what are the two quantities that both of those equations have in common? Is that a hand, Chris? That looks kind of like a hand. Right? Chris, what do you got? So why the x? Notice they both have a y and they both have an x. All right? And importantly, we can see that the x is kind of like in here doing something. We can see the x is in here doing something. And y is set equal to those equations, right? Y is set equal to this expression and to that expression. But you would argue that these are obviously two different relationships. So think about when you plug one. You plug one into the first one. What are you going to get? When you plug one into the first one, what are you going to get? Mark, what are you going to get? You're going to get nothing. So x equals 1, y. How will you plug 1 in to this one? What are you going to get? You're going to get 3 instead of 4. 3 for 1 is 3. Right? So they both are defined relationships. They're both functions. Right? Because all they are they're representing two quantities. And they represent two quantities. Let's talk about ways that we can represent. What I'd like you to do is please copy down this mapping diagram. Please copy down that mapping diagram. Once again, copy down that mapping diagram. And as you copy down the diagram, what I want you to do is I want you to think about what is going on in the mapping diagram. So what's happening in it? What are the things you notice about it? What are some things that are interesting about it? What is it trying to tell you? Right? Is there a relationship there, and what might that relationship mean? Do you need that tape? Oh my God. All right, so I'll take some volunteers. As you look at that, what do you notice? Like, what's something that you just kind of see? What's something that you see up there on the map? Maybe it's obvious, or it's not obvious. Justin. And a line. And there are lines, and what's on the other line? Is there anything special about them? They're straight. Okay. Enrique.
8 and 23.
8 and 23 have the same temperature. And what else do you see up there? There are arrows on the straight line. Very good. And the arrows are going from which set to which set? Right? Yeah, so the arrows are going from time of day over. Okay, what else? Anything else that you're pulling out of there that you think is worthy of saying about the rest of the class? So when you're thinking about a mapping diagram, when you're thinking about kind of these two quantities, right? So we can say that the left one is quantity A, we can say that the right one is quantity B, right? And there's a relationship here, right? And there's a relationship that is obviously going in a particular direction, right? Another way that I could call A, I could call A my independent variable, and B my dependent variable. So what I want you to do, as you get those two words copied down, independent variable and dependent variable, I want you to think about why is this side, why is group A the independent variable? And why is group B the dependent variable? Please, take 30 seconds. Chat with someone around you. Why is group A independent? And why is group B the dependent variable? Think about what those terms mean. Think about what it means to be independent, what it means to be dependent. And not in terms of a variable, like what does the word dependent or to depend mean? Yeah, exactly. Right, what does it mean to be independent? Alright, there were some thoughts out there. Allie, what was your group chatting about? Which one? Alright, so what does dependent mean? What do you say? No, not him. What did he say? Yeah. Okay, that you depend on something or someone. So if it was a dependent variable, it would be depending on what? It would be depending on your independent.
It would be depending on the time.
Yes. So in case you missed what Enrique just said, and I'll get to John and Monique in a second. What Enrique just said is that the temperature depends on the time of day. And not the other way around. For instance, if I said that it was 87 degrees, Nick, it's 87 degrees for what time? So it's either, right? We don't like either, right? We want specifically. And that's why Enrique's comment was so great, because it doesn't work going the other direction. The temperature is dictated, it's dependent on the time. John, what were you going to say? And then we'll go to Monique. Yeah.
I was going to say that when the independent variable changes, it directly changes.
So that's the exact type of relationship they have, right? As you change the independent, the dependent changes as well. Monique, what was your thought? Oh, good. Yes, it is. It's the input and the output. You put things in, that's the input. You get things out, that's the output. That's exactly right.
So it's like an X and Y chart.
Right?
When you made that, I thought it was wrong.
Chris, oh yeah, you had a thought too. Yeah, this is like military time, so I feel like
So 23 is
8
11,
p.m.
right?
It seems like a lot of work on my part. And you know, as you notice, I'm a little late. So, when you think about generally, so mathematically, think about generally, when you have independent variables, when you have inputs, mathematically, a volunteer please, how do we represent them? So mathematically, yes, okay. You represent the input, the independent variable as x, and you represent the dependent of the output as y. Right, that's your input and your output. So, the big question of the day, that people have not been able to remember, what you call the values, the possible values of x for a relationship. What you call the possible values of x for a relationship or a
Problem.
What do you call the possible x values of a function or relationship? John? No. No.
Quotation.
No.
Function.
No. No.
Answer.
No.
Possible values.
Numbers. No.
What does it start with?
That's a D.
Denominator.
Domain.
Who said that? Is it domain?
Because they're all like, oh yeah, I've definitely heard that word before, and I should have remembered it. That
So
was
is
why.
domain the answer?
Yes, domain R is. And then how about for Y? What do you call the possible values Y? Justin? So, what you need to know from what's up here. So proper definition, so the domain, all the possible X values of the relationship. So the domain, this will be something good to write down, is all the possible X values of a relationship. The range will be all the possible Y values of a function. Let's see, domain, that range is Y. You want me to repeat on those? So again, the domain is all possible X values of a relationship of functions. The range is all possible Y values of a function or a relationship. So there are a couple other ways that we can represent a relationship. So another way that we can represent it is a table of values. Right, so go ahead and make a little table of values. And what I'd like you to do in your table, you can call this input-output, you can call it X, Y, right? You can call it independent-dependent. I'm just going to call it input-output. How would you like you to fill in the table of values? Fill in the input, fill in the output. Yep, from the mapping diagram. So from the mapping diagram, so using the mapping diagram, go ahead and fill in the input and the output. When you fill in your table, what do you fill in? So, Chandler, what do you fill in? The order doesn't matter as long as you correctly matched up your relationship. Right? So you could have it as 8, 15, 3, 17, 23. As long as your inputs and your outputs were matched up, you can do it. So that's the kind of the second way you can represent it. If you wanted to take this right here, the input was 3, the output was 82. Discuss with a partner how you would write this input of 3 and that output of 82 as an ordered pair, how would you write the input and output of 3 and 82 as an ordered pair? You got 30 seconds. Go ahead and figure it out. How would you write it as an ordered pair? If you don't know what an ordered pair is, think about a coordinate pair. Think about a coordinate pair. You need a different word. Coordinate pair. If I have your attention, please, and thank you. Nice to know what I'm waiting for you guys. Christine, you and John were talking. How would you write that as an ordered pair? Do you need anything else? Really? That's an ordered pair because an ordered pair, also known as a coordinate pair, right? X, comma, Y. Well, what's your X? Your X is your input, right? That's what an equal is. What are your inputs? Are your independent variables. All right? The last way that we could represent a function. So the last way, right, is we can, well, the same last way, a function can be represented as a set of ordered pairs. So like you do now, take your table of values and write them all as ordered pairs. Can I go up? Yeah.
I think 87 and 23 is 87.
You're going to ruin the noise today. Yep. Like, seriously. Alright. So, the ordered pairs here, we already had 3 and 82 from John and Christine. Then you have 8 and 87. You have 15, comma 96. You have 17, comma 105. And you should have 23, comma 87. Oh. Not it. Alright, so far we've had a mapping diagram, that was the first one. Mapping diagram. Then we did a table of values. Then we did an ordered pair, set of ordered pairs. The last thing we're going to talk about today is we can represent them by their domain and by their range. To do that, this is the notation that we're going to use. We're going to do a little C, a colon, and then we're going to do one of those fancy brace things. And we're going to put,
You have to do that?
do something that looks like a brace. Yeah.
Why?
So what I'd like you to do for the domain and for the range is you should simply list the x value and simply list the y value. Yeah, inside the braces, you just separate them with commas.
They do what?
So for the domain, what are the x values for this relationship? I think there are 5 of them, right? We go right
You
here.
just put it in those little,
Yeah.
there box?
Right. That's exactly
So
what
you have to do that.
Yeah. Just like this. Do domain and do rent. With the R little colon like that. That's how we'll kind of do a question. Yeah, just put them all inside. Yeah.
Oh, you put all of them inside. You don't
Yeah.
do it individually?
No.
As a
No. Be like, you know, put all 5 numbers inside. Yeah.
You can do it.
Might have your attention, please. So what is the domain for this? Riley, what's the domain for this relationship? And Sophie, what is the range?
Is that all the wiring?
Yes, ma'am.
8705, 8796, It's like the 871.
Yeah. Right.
Oh wait, if you do put a trust in there,
Don't.
so the
All right. So looking at this, what questions do you have on the 4 ways to represent the relationship?
So
Read
what,
it.
are we always gonna get like a little circle like this? This is just one way to.
That's one of the 4 ways. So I can give you a table of values and you could write a mapping diagram. Other questions? Okay, you have 4 minutes. So what I'd like you to do in 4 minutes, I'd like you to start by copying down this mapping diagram.
Oh, Phil.
And then I'd like you to please write it as a table of values and a set of ordered pairs, and then write it as a domain.
Do you have to make like circles and squares?
You just kind of have, you can just make it mostly circles. I just have lots of shapes to play with, so that's okay.
So nothing goes.
Correct. So while you're working on this, and you still have 2.5 minutes left. While you're working on this, I do have a thinking chip available. For those of you who are new to class, or who totally forget because I read you, you can exchange thinking chips for stuff at the end of the course. Right? So stuff, you know, being like, stuff. Not academic stuff, you know, like sodas and Gatorade and shit. You know, like that unhealthy stuff that I shouldn't be bribing you with, but I totally am. So, what I'd like to know for a thinking chip today is, look at 1983. Don't shout anything out. Look at 1983. Something happened here. There were 32 hurricanes. Now, that could be a total lie. I just made it up. It probably is, because I totally made it up. But what I want to know, when we think of descriptive statistics, right? When we think of statistics, there is a word that we use to describe a year like 1983. Oh my God. So I think your hand first. Yeah. No one's known that all day.
Wait, what was it?
Literally, no student has known that all day.
Wait, what was it?
It's called an outlier.
I knew that.
Really? Literally. I've asked that, I mean, I've seen what, 75 kids in geometry so far? No one has known the answer to that question. I've had to drag it out of them. I even gave them the OUT early. No one got outlier. It has nothing to do with what we're studying right now. It was just for a bonus. It was just for a check.
You're just gonna ask like random things.
Yeah, like random math questions.
I was like,
Okay, what's up?
it has nothing to do with it.
Do I have a thinking chip if I get it right?
No.
Okay. What's up?
Who's your favorite football team?
I don't really follow sports a whole lot. Sorry.
Yeah.
But I like playing it a lot. I really don't watch any. But if the Steelers were in the Super Bowl, I'd probably root.
Too bad
Like I don't even know. Yeah, I'm an Ohio State alum. I don't even know anyone. I'm a horrible. I'm a good representative though. Oh yeah, I mean I play football. Did anyone, as you wrap up this, did anyone have any questions, thoughts, need any clarification on either the table of values, the domain and range, or on the order check? And we are not done yet.
With the range,
Yes.
the one that has it next to it, the 8.
Thank you for bringing that up. Okay, so there's an 8 right here. What's going on with that 8? Why is it there? So it's there, but we're not sure why it's there because based on the inputs that we're given, none of the outputs produce. None of the inputs produce that output. So is that part of our output?
No.
Of course not, because none of the inputs go there. Because outputs are what? They're dependent. They're dependent on the independent variable. So to be dependent on the independent variable, right, what that means is that you have to have something going on. All right, what I'd like you to do now is I would like you to turn to a partner. There are 4 ways to represent a relationship that we've talked about so far. You have 30 seconds. Please know those 4 ways. Please know the 4 ways to represent a relationship. Is everybody okay out there? Okay. You know, I see you staring over there and crying of concern that anything happened. I had to like do something before. If I have your attention, please, thank you. Thank you. My group in the back, thank you. All right, let's go around the room here. Michael, what's one word? You ordered pair, didn't order pair. Other Michael, Michael Griffin, what's another one besides the ordered pair? That's it. The domain and range. Good. Chris Smith. A mapping diagram. And what is the last way? Table of values. Right? So those are the 4 ways. So we're going to look at one of those ways. We're going to look at two. So when is a relationship not a function? So we've been talking about, I'll be right at the end. I'll think right? We've been talking about all these relationships, and I started off class by saying that a relationship or a function is a special type of relationship, right? And there are some limits, right? Well, we're going to talk about one of those limits right now. And really, in all practical terms, the most important one. Enrique, do you know when a relationship is not a function?
I'll think yes.
Okay.
Is it when the Y has the same length as
There's like two.
Yeah, you get what I'm saying, right?
I do, yeah. No, you're exactly right. When is a relationship not a function? When you have repeated inputs matched to different outputs. Or, put simply, when you have the same x value show up more than once. I know. I got you. So take a look at my mapping diagram down there. You can see the left triangle, and I'm just using different shapes. The left triangle has a 1, a 3, a 2, and another 1. The problem there is that if I were to ask you, David, when I put 1 in, what do I get? 4 or 9. That is not a function. It's still a relationship. We're not taking anything away from that. It's still a relationship. But it's not a function because it has a repeated x value that goes to a different line. If you were looking at it in the table of values, you can see that 1, 1, 2, 3, 5, 9, 8. Well, in terms of our discussion, that's the problem with this is right here. It's that part. It's the fact that 1 produces 2 different outputs. So I have 1 input creating 2 outputs. That is not a function. That's the main restriction that we're going to have on a function. So, what I'd like you to do to wrap up today, I'd like you to turn your circle.
I have a
Just grab one from near you.
we sit down there.
So, here's my question for you. Look at the following table of inputs and outputs and tell me, yes, it is a function. No, it is not. And so, yes, don't shout it out loud. Let everybody enjoy this moment. Yes, it is a function. No, it is not a function. Does it work?
My number.
Here. Oh. Hang on to your clicker. I have another question for you. You can pass up. Hang on to your clicker. Can I have your attention, please? Thank you. So once again, I said you're okay to pack up, so just keep your clicker out, because I do have another question. Does anybody still need to put an answer? Yeah, apparently it's you. All right. I had 5 people, so maybe 6, respond yes. I had almost 25 respond no. Why is that a function? Why is it a function? Now, there were 6 of you. Why is it a function? John, why do you think it was a function? Why not this?
Because it is sort of like a well, an equation that matches the output.
Okay, so think about what John just said. Why might John be wrong? Chris, why might John be wrong?
It has to have the same output. It can't be a different output. So
Your other question to get out of here. Yes or no? Is that a function? Is that a function? You have 15 seconds. Please respond. I need to know. Is this a function?
Wait till the.
About 5 seconds if you want to respond. You stay your seat. It's over. Chris, Enrique, download. Okay, so is that a function?
Yes.
Of course it's a function. There are no repeated x values. The output has nothing to do with it. Oh, kill him!
It also is a rapid.